Hello, this is Paul Silver, Global
Unmuted.
Manager from Dassault Systèmes, and it is my pleasure to welcome you to Real-World Strategies to Accelerate Electric-Connected Autonomous Vehicle Advancement. Our expert industry speaker today is Rick Sturgeon, who is Global Senior Industry Consultant from our company. Rick is a 30-year automotive industry veteran with C-level executive experience from several highly respected companies. His current passion is focused on the autonomous electric vehicle sector, consulting with today's leading OEMs and EV innovators. Today, we're exploring the many challenges of developing and producing new EV mobility and what it takes to stay productive and profitable in today's competitive industry.
Almost everything that has enabled modern society to evolve and prosper depends on mobility. The early innovators brought trains, subway systems, and industrialized the mass production of cars, empowering the world with the previously unforeseen freedom of movement. But today, these industries are facing a massive revolution. Manufacturers must not only comply with increased regulations, but entirely redefine the future of mobility. Cities, citizens, and industries require smarter, safer, more sustainable, customized, and personalized experiences. From electric autonomous connected vehicles to bold new shared mobility options and services, driving a fundamental transformation of how we transport people and goods, unlocking a landscape of new profitable and sustainable opportunities. Dassault Systèmes 3D Experience Platform is the enabler, unleashing the next generation of vehicle innovators by enhancing the real world with the virtual world, connecting and simulating the entire life cycle and extended supply chain. From planning, design, engineering, and testing to manufacturing and experiencing through a single collaborative environment with full visibility, capturing vast shared intelligence, accelerating new exciting vehicles and shared mobility services on target with shorter cycle time, transforming the way the world moves by harmonizing product, nature, and life. In a future made possible by virtual universes, experience the future today.
Let's get directly to our first strategic topic. Right now, in autonomous electric vehicle development, we're witnessing some overall differences in process, organizational structures, systems architecture, powertrain, simulation, and manufacturing strategies. Considering traditional OEMs versus the new EV innovators, what are you seeing as an overall EV development approach lately?
Thank you, Paul. Well, the EVs definitely start with the customer. They understand the requirements at a very deep level. And once they've done that, they start with actually the battery chemistry. And they build the battery, its chemistry, and its size, and the packaging to meet what the customer needs. And then they wrap the rest of the vehicle around that. In the electronic space, there's a major difference. As you know, the EVs are much more, I think, like half electric and software. And
right.
With a typical vehicle from the traditional OEMs, there might be 100 processors. In the new EV companies, they might have one processor for control and one for entertainment. And this allows them all kinds of flexibility to meet customer needs, do downloads, uploads, etc. Now in the body, Tesla went with a unibody, but all the rest standardized on what's called a skateboard, where the batteries are underneath, and then there's really what looks like a skateboard on top. Then they wrap the coach, the body, and the top hat around it. And they use very, very heavy use of simulation. And this allows them not to have to buy all the prototypes, but one of the major EV companies actually made no prototypes in the core airflow body, which is a really expensive spot for most of the traditional OEMs. And they produce the lowest drag ever produced without ever running in the wind tunnel. And they vertically integrate. They do as much as possible, minimize their use of suppliers, and they do some really cool things too. I think one of my friends has a Tesla, and one day he saw this feature that sort of showed up, and it was called I Feel Lucky. He pressed it, and the autonomous feature just started taking him places where he'd never been. So this ability to really do more than the vehicle, but really connect with the owner through the electronics is a huge difference.
Excellent. Rick, in contrast to the EV startups you described, how do the traditional OEMs approach ACES, or autonomous connected electric shared vehicle development? And please don't share any confidential details you may be tempted to share.
Right. So the traditional way that a vehicle has been done for many years is they have a whole sort of stable of powertrains and structures. And when a chief engineer gets a new vehicle, he gets the customer requirements, and they say, okay, you got to meet those requirements, but you got to pick one of the powertrains and one of the structures and use that and change it as little as possible, and then execute your vehicle. They're very horizontally integrated, hundreds, thousands of suppliers. And in the ECU space, just to give you an example, they might have 100 ECUs, which the electronics and software are really meeting the requirements in each area, and they're all daisy chained on a CAN bus. But that really limits flexibility. And the advantage, though, is in that scenario, all the parts are highly toleranced, fully specified, certified, and 90% of the engineering is done, and you know it's going to work. It's, you know, it's there. So it really is cost effective and reduces warranty and so forth, but it's really hard to make changes. Just to give you an example, though, now that's how they always did it. One of the OEMs a couple years ago started to use that process for an ACES vehicle. And because with an ACES vehicle, to package the battery, you destroy the structure. And obviously the electric motor really is a whole different powertrain. So they went through that, though, and tried to use their normal process, and they ended up spending 3.5 times what they normally would to develop a vehicle. So that didn't work. So they really had said, this is the traditional people who are doing a lot of EVs now. How do you do one-off vehicles? In the past, we had it 90% done and we just tweak it. But now we're starting from scratch. And they look to NASA, they look to the aerospace industry, to defense, and they found that they had adopted a concept some years ago called model-based systems engineering, where the specs aren't just something you write and throw over the wall to your supply base, but there's a model of the specifications and even the validation of those, and it stays live throughout the project. We see every OEM using that right now and beginning to develop vehicles.
Excellent. I've got another quick question for you. Considering common outcomes from very different approaches, how do you see today's OEMs and innovators organizing themselves?
Well, I was in a startup at one time, some years ago. They start by hiring the very best people, and they co-locate them together. Their processes are very ad hoc. You know, if there's 3 of you, you start, and then once you're 200 of you, you're still working in that way. And now, I'll give you an example. Some years ago, I was out at one of the major, really successful EVs, and a lot of them use our 3D Experience platform, and we'll get to that later. But you know, there were some startup issues, but they stuck me back with IT and our team, really, and said, CIO came in occasionally, said, don't go out there, it's all confidential. Well, at a certain point, I said, you know, I need to go to the bathroom. So I sort of wandered out to the bathroom, and then from the bathroom wandered out into the secret area and said, where's the guy that runs engineering? And I found him, and as is typical in most of them, he'd come from a very successful OEM and was, you know, going to make his fortune at the startup, which he probably did. And I knocked on the door, and you know, we talked a little bit, knew some same people, and looked at backgrounds, and we got into talking. And I said, well, how's it going? He said, well, this would best explain it. See this form? I brought it with me from XYZ, major big corporation. It's how you get a prototype. And he said, I used to just fill this out, hand it to somebody, and 3 months later, the prototype came back. He said, there's nobody to hand this form to. And so, yeah, that's real. And so what that forces is everybody to come out of their silos and really work more similarly to what Henry Ford did originally. You know, he used to sit in the room and just yell at people if they went in the wrong direction, or maybe innovate. And, you know, the Lockheed Martin Skunk Works, and they developed very quickly some of the major things of the past century, really, in that model. And
Right.
But in any case, that's really how they do it. Now, the weakness in the traditionals is they have all the suppliers. You know, they really, in many of the functional areas, don't even have the expertise in-house anymore. And that's okay, except when you have to do something new or you have to make a lot of changes, it's very inflexible. And that's the problem they're facing now. And you know, we have a product called No Magic, which is a model-based systems engineering tool, which is very pervasive in the aerospace industry, and it's moved heavily into automotive. So I see a lot of changing going on.
Great. So here's another challenge. Given the amount of legacy systems and data that the OEMs have versus the relatively clean slate of the new innovators, what do you see are the systems and structure challenges that are being used to develop future mobility?
Well, the newer companies, I'm not sure what today, but the top 10 value-wise, at least they were, are using our 3D Experience platform. And there's a reason for that, and we'll get into it. That's the tool, though, that when they start up, they could have the same capability with the three of them through that tool that Boeing or Airbus are using to create a plane. And that's a huge opportunity for these people to really grow quickly. And they do. And in essence, what the difference is most of the legacy PLM systems, ours included, were really primarily share files. We all know about sharing files, and everybody needs a file manager on their PC or in their PLM system. It does a little bit more, but that was the main thing. Everybody can see a common file globally. But what we've done, and hopefully others will follow, but right now, is to take all the data out of the files and make it like Google. So you can query it. You know, somebody working over in simulation or manufacturing can see real time what's happening in engineering. And that really facilitates the collaboration that these small companies really need as they grow out of their Obeya room, and which is the term that Toyota used for everybody co-located. And they start to, you know, with COVID, they're working from home. And so we see a lot of that. Now, the traditional ones, I was a traditional CIO at one time, but in one of my past lives, we had one of the big consulting firms count how many engineering or product development systems we had. We had 750 of them. And our IT was trying to keep them all coordinated. But now the CIO, and you know, they really can't. And so the CIO, you go to, well, why don't you go to the cloud? Why don't you fix this? Well, CIOs aren't dumb. They're really told, though, by the companies, the traditional companies, you have to do more with less money every year, and boom, right. Boom, boom. And so the realization that it's time to make the jump to the cloud and really create this real-time product development capability is something that, with a few exceptions, I'm starting to see hasn't hit the legacy companies, but they better get with it, because I think the newer one can probably produce a car or a vehicle for, I'm guessing, probably a third the cost and probably half the time. And so we're seeing the valuations in the market reflect that. Okay.
On a related topic, we're seeing major differences in how the innovators versus the OEMs manage the development of their powertrains. That's the battery, the e-motor, et cetera. How do you see this difference in approach?
Well, they start with the battery, and then they work to create the under chassis to protect the battery. And then they use heavy multi-factor simulation to optimize the skateboard from the chemistry through the battery cell, and how it's developed, from the electric motor to clear through packaging. And that really, and they open up the front of the vehicle for storage. It's really a whole different design. Interesting story, though, and it goes to the powertrain. One of our customers that uses our platform is called Canoo. And we had their vehicle at CES this year sitting in our booth, because they had actually developed the whole thing on the cloud, which was the first company to do such a thing, a whole vehicle. And a lot of people were coming around, and I know a lot of the engineers from the various OEM companies, and they were coming and looking at it, and they said, you know, Rick, they got this wrong. I said, oh, really? And, you know, I'm not a powertrain expert, but it was not just one, it was several. You know, they didn't understand. So I went over to the expert from Canoo that was there, one of the engineering guys, and I said, you know, you got it wrong. He just looked at me and he said, no, they just don't understand. And I said, what do you mean? And he said, well, they're right in the sense that if you were just optimizing the powertrain, there's probably, we didn't do it exactly perfectly, but we optimized the vehicle. And by doing it this way, we actually moved the interior space to one vehicle class higher. You can think of it from a sedan to an SUV, and still meet the requirements of the powertrain for this vehicle. So I went back to the friends that have been there, and I said, you know, here's what they did. They actually got it right. And so then all of a sudden, people from the OEM started showing up with cameras, you know, taking pictures of how they did it. But it's just an example of where innovation is really real. And they did a lot of that with simulation as well. So, you know, because it's really, there's some risk in changing how people have already done it. So you really need the simulation to protect you. Okay.
Rick, considering your executive experience with a leading seating supplier, let's move into the interior development. I'm curious about this one. Considering all the surrounding technologies and their impact on the passenger and driver spaces, how do you see them managing their different approaches for developing their interior experiences?
Well, in the interiors, you know, maybe people, you probably know this, but there's really a lot of data to support it. People come to a showroom because of the advertising and maybe some of the hype around the vehicle, but they buy the vehicle because of the interior. And so the new companies know that they actually spend more money on their interiors and put more weight into their interiors than what the traditional OEMs do. And they do all kinds of things, like one of the Tesla models, they actually went with pedestal seating in the back row, and it was white. Now, that's really heavy, and white has typically a lot of warranty problems, but I'm not saying they got it wrong, because they're selling a lot of them. But it's heavier, more expensive, etc. So, and they're generally differentiating on look and feel, and you know, to get them to purchase. And the content level was a lot higher, and they're using a huge amount of touch because they have a lot more electronics. So they're starting to integrate the controls into the interior. Now, if you go to autonomous, that's a little different story, because there you have less need anyway for the steering wheel and the pedals, and they start focusing on other functions. And really the theme is relax, be entertained, and control. And the seat changes with that. And obviously you still have to meet the crash requirements, but there they really expand touch. You know, it's everywhere. You know, you lean over and you think about some entertainment thing and touch, you got it. And then the third category is shared. And that's even different again, because it's not just the passenger, you're also designing it for the provider. Now, the perfect shared vehicle would be one of the old New York City taxis with a hard seat and you know, covered with plastic, and then you would hose it out with some type of COVID killer every time somebody gets on it. Well, they're probably not doing that, but in essence, there's that type of thinking about how do you change out interiors, maybe every few years, like the airlines do, but in some cases, every rental. You know, so there's a lot of innovation going on in that space. And really, as we're going to see later, a lot of the money is into the shared. They're driving a lot of the innovation.
Great. A lot of my engineering buddies are always interested in what's under the hood of some of these newer vehicles. How do you see the electronics and software changing as the vehicles become electric and autonomous?
Well, I want to walk you through a study that McKinsey did, really not a study, but they presented at the Electronics and Software Show earlier this year. Go ahead to the first slide. So I'm just going to summarize, but on the left is 1 through 5 SAE levels of automation. And if all the little black boxes are, you know, an indication of the controllers. Well, you see at level 1 and level 2, there's just controllers all over the place. And today that's still the case. But as you go to level 4, there's something that's coming into play called a domain domain controller, and that's sort of subsets of the vehicle. So they're really starting to pull a lot of the software and the smarts out of a lot of the sensors, still leaving a controller there, but it's not doing much, which reduces its cost quite a bit. And as we go to level 5, we get much more of a central computer, probably one or maybe even a backup for control, and then one for entertainment. Now, these aren't the same, let's say, computers that exist in the world today, because they have to have two components in them. They have to be event or time driven, which most are, and also event driven to really meet a lot of the safety requirements. And some people are starting to roll those out in the early phase, but there'll be a huge growth in the electronic side of this, and then we're going to look at the software. Next. So here's one that across the three sort of vertical columns are the current ICE vehicles. In the middle are the shared vehicles and a lot of the trucking, and on the right are the more EVs. And the black is 2030, the amount of money spent in software and electronics, and the blue is 2025. Now you'll notice that not much is happening between now and then with the typical ICE vehicles. Not that they won't add a lot of capability, but at the same time it'll start to scale, so they try to keep the price about the same. If we go to the far right for the EVs, there certainly is more software in them, but even then, even as the software increases, it commoditizes and stays about the same. The interesting one to me, and I didn't really catch this when I thought about it, the money and the software growth is through now and 2025, it is driving everything in the shared or fully autonomous vehicles. And then going into 2030, that cost will reduce significantly as it scales. Next. Now, if you talk about software, if we look in 2020, there's about 34 billion being spent in that space for software in the automotive, and that grows up to 84 billion, which is a huge growth over 10 years. And to put it in perspective, and also the growth, about 30% of that cost will be in validation and certification. And the real interesting thing that I saw is they're expecting it'll take 250,000 software engineers to actually execute this, and there's nowhere near that now. I'm not sure the number, but massive growth. Next. Now, some of this concept of how fast will we grow to a centralized ECU. Now, there's two modes, and it really is tied to how fast do we go level 5 autonomous. But if we really go the fast route, as you see on the right, we'll have half running in a central computer in that time frame. Now, that really changes everything, because it means that, well, in any case, we'll summarize at the end. Go to the next. And then sensors, that's another part of it. Level 2 is sort of what we have today. You can see across the top LiDARs, radar, cameras, and we have them on the vehicles today. But as we go to even up to level 3, they rely a lot more on them, and they start to add redundancy, especially in the front of the vehicle. And then when we go to level 4 and 5, they're just all over the vehicle, which in today's dollars would be very difficult to justify the cost. However, everybody is working to reduce these sensors, to take the software and at least the very expensive processors out of them and centralize them. So huge activity going on there, which really ties to the other slides. Now, you could go to now let's just summarize what we saw there. First thing, it's going to mean that software and hardware separate, which really reduces a lot of the complexity in the software, number one, but secondly, it allows a whole bunch of other people to enter into that space, especially some of the, let's say, more high-tech companies, and a lot of more standardization. It also is going to force huge collaboration between the OEMs and the suppliers, more than's ever been done. No throw it over the wall, because in that central controller, you're going to be developing how the vehicle runs together. And the collaboration piece of it is big. And third, the concept of MBSE to manage all of this is real important. I actually, for the last couple of years, have sat on the SAE committee that's creating the standard on how you validate a level 4 and 5 autonomous vehicle. And there's about a dozen of us that come regularly. I listen mostly. There's some really smart people there who you might expect, but we're very close. And when you look at the what's there and the amount of, let's say, edge cases and things that you'll have to certify, it'll have to be a very controlled both design and testing and a lot of simulation, but it's exciting because I think that they can be made safe in the end.
Customers expect new mobility solutions to be innovative and enjoyable. So mobility providers need to turn complex performance requirements and safety standards into new driving experiences. Imagine having your multidisciplinary teams on the same digital platform so that they can collaboratively develop and virtually validate advanced mobility solutions and then prove compliance with safety standards. Smart, safe, and connected is the solution that brings together mechanical, electronics, electrical, and software disciplines to continuously develop innovative solutions that will deliver a competitive driving experience. As a result, mobility providers can accelerate decision-making by allowing rapid trade-offs between new concepts, streamline collaboration and traceability between disciplines and suppliers, improve innovation and reduce time to market thanks to continuous integration and simulation. Advance your competitiveness in the marketplace with intelligent, desirable mobility experiences that's smart, safe, and connected.
Heard the concept of virtual twin around the industry lately, especially within the context of digital manufacturing. How do you see this approach impacting quality, productivity, profitability, and even cycle time to market?
Well, that's very true, and there's been a lot of let's say virtual twinning up in engineering and actually some down in manufacturing in the past. But those two worlds are coming together, where as things are being designed, as products are being designed and the plants are being developed, and ultimately the process lines or manufacturing lines, can be done together now. And the companies that have gone to that mode are finding two things. One, they're designing products that actually are manufacturable by using this capability, because it really provides a collaboration space for the product development teams and the manufacturing engineers to work simultaneously. If you think about it, and in one of my past lives, we found that we weren't engineering or design and manufacturing weren't working close enough together. So we did like 24 initiatives to make that better, and we measured it again, and it was getting worse every year. And that's for a lot of reasons. It's the globalization and everything else. But with this technology, it really allows, well, a lot of times the manufacturing engineers don't even really heavily look at the design until it's pretty far along. Once you start doing this capability, it gives them a view into what's happening well ahead of time, and they can give their input. And it really does have an effect on the launch costs and the warranty costs and all the costs, because once it's released from engineering, it's like 90% some baked. You just can't change it a whole lot. So this allows a great capability. So yes.
Excellent. Great. Now, we understand that the OEMs and innovators really can't succeed on their own in this competitive industry environment. Many depend on their strategic suppliers for new innovation and collaboration. What impacts do you see within the context of the OEM innovator and the supplier relationships?
Well, historically, as we got to earlier, it's send out a paper spec, take competitive bids, and deliver the product and meeting SAE standard tests. And it's a pretty tried and true model. Most of the vehicles we have today have been done that way. However, going forward, especially as we have such massive change to the vehicles, really collaborating, using the cloud and bringing the supplier much closer to be part of the design and the decision making and the changes. Because if you make a change in the standard system, and there are changes, they're very expensive, very disruptive. I once had a chief engineer tell me that he said he wanted a software change 3 years before launch. And because it had to pass 10 ECUs, they said that was absolutely impossible. Some of the new companies make changes every night. So that gives you an idea of the differences that can happen. Well, the suppliers need to be engaged in this model. And again, the use of MBSE, the use of the cloud, aerospace is actually driving that approach to integrate the suppliers much more into their design. So, and then the other side of it is IP protection for the suppliers, and that's all being considered. So it's really a big change in that space, Paul.
Excellent. Rick, another popular topic for cost savings and cycle time reduction is virtual simulation. How are today's innovators using simulation tools to validate their vehicle performance?
Well, certainly the concept of using different analysis tools has been, everybody's done it. The OEMs have done it heavily for years. It's just because of the cloud and because of the advances in computing, the capabilities have just gone exponential. And so the new companies just go with it because they don't want to make the prototypes, they can't afford them. The older companies, however, and I was in one, to give you an idea, I had all the different groups, the analysis group, the testing group, the design group. And what would happen is the analysis people would do their analysis, the design people would go with it, you'd run the test, and it wouldn't exactly correlate. You'd make the prototype is the big part of it. And so the traditional OEMs really feel that unless on every possible test you can statistically show that your analysis always matches the test, then they just have difficulty taking that risk. But when we would go back and try to figure out why the test failed, and at that time I was involved with probably delivering half the automotive seats in the world and maybe a quarter of the interiors and a bunch of testing facilities, we would find that almost the majority of it was that the part that was made in prototyping didn't really match the analysis and probably wouldn't match what was produced. So you're never going to quite nail that one. And so that really is keeping a lot of the traditional OEMs back, but the newer companies go with it. And I think it was shown in one of our customers that the analysis is actually much more accurate than a wind tunnel because of the problems in testing in the wind tunnel. So rather than me continuing on that, let's look at a video, Paul, that just gives a sense of how pervasive this is.
Rick, what about the new wave of autonomous vehicles and mobility sharing services of the future?
Well, of course, every OEM is making an EV, from a product side.
Right.
And however, there's a lot of companies that are doing a lot of fleet vehicles. That seems really hot. You can just Rivian, Canoe, it just goes on. And but it's not just the vehicle. It's extending out into the smart city, I guess. We were real involved with the city of Singapore and several other of the smart cities, and that's a long time ago, actually. And now we see the more advanced, let's say, integrations coming into play, which really focus around the passenger in the vehicle or the ride share service, and really optimize that vehicle or that experience for the passenger out in the city. And so there's a whole series of services, activities, even to the point of which we have a great involvement in, is really we call Quintic. It's a product that'll just optimize every movement or every of the vehicle or where it needs to go next, et cetera. So that's a huge ballooning space that I know sort of everybody's trying to enter into, and it's a space for pure innovation. Now, one of the things that I got real involved with smart cities some years ago, and especially the concept of autonomous vehicles running through them, and everybody isn't sure what will happen when, but I convinced myself that it will be real when I found an MIT study from some years ago that assessed how long does it take a vehicle in city traffic to get through a stoplight, and it takes 90 seconds on average. So if you go through 10, 20 stoplights on the way to your work in a big city, that's how much time it's going to take you, plus who knows what else. However, if every vehicle in that city is a smart autonomous vehicle, it only takes 3 seconds a stoplight, because they roll them into swarms and you go through the lights back and forth. And I've actually seen heavy trucks being tested in that fashion, where there's no red light at the intersection. They're just crossing, three sets of trucks, backs all tied, or trailers all tied together, one and the other. So that's going to be real. And there's so much money driving that, because that will extend out how far people can live from the center city, because they'll only handle about an hour drive. Now they can live for more miles out. It opens up a lot of real estate in the city, et cetera. So that's really exciting. And I don't know who will do that first, but there's so many vehicles coming into play in the next few years. I really expect that for the cities.
Sounds like great potential and opportunity there. So considering all these perspectives and various strategies, what is the optimal plan for productive, profitable future mobility?
Well, let's take it back to the people that are probably listening to this. The number one thing is the top leader of your company, preferably the CEO, but certainly a very powerful person, is a change agent, almost regardless of the size of the company. And they will understand where you are and where you have to go, and will sort of break through the change. Change is always hard. And then secondly, you need to give your design teams the freedom to innovate. And what do I mean by that? By definition, the new companies have freedom to integrate because they're the only ones there. But in the traditional companies, you have all these functions, as I said, 90% of the design is already done. So they often set aside a small group, a new vehicle, whatever, and say, go ahead and innovate. But as soon as they've innovated, and I'm not saying it's wrong, but the company comes in and every department comes in and says, well, you need to use my thing and take this out, and it's too risky, and on and on and on. In the end, the innovation is damaged. Now, not in every case, but it's the past holding back the future. And change it around. Give the new people in the new group the power to say what they want, rather than the people from the more legacy to saying what they're allowed to do. And then you need modern systems, preferably all in the cloud, and you need to engage your supply base and throughout it, and optimize your supply chains. And once you've done that, you can even optimize your factories to cut the costs. And the third thing is, it's just time to make the difference. The opportunity only comes around in this industry every 20 to 30 or even 50 years, and this is the time to focus. Take risks, create change you will be proud of for the rest of your lives.
Rick Sturgeon, a global industry consultant from Dassault Systèmes, thank you very much for your time and expertise. We appreciate your being with us to explore real-world strategies to accelerate electric, connected, autonomous vehicle advancement. For further details, or to explore your vehicle development, engineering, simulation, manufacturing, and production solutions, go to 3ds.com/transportation. Thanks for your valuable time.